Okay, everyone, we will continue on with our journey through exponents. On this assignment, in these examples today, there's only one rule I'm going to cover, and that's when we add exponents. What I have at the top of this page, this is just a little symbol form. Okay, when you multiply the same base, you get that same base, but you add the exponents. That's what it looks like on the formula sheet that you get for the PSSA. Okay, so last time we did stuff like this. 4 to the third times 4 squared. And I ask you to write it out on a space to get credit. And then add the exponents. Don't take a shortcut. And if you wrote it all out like I showed you in that last video, you got full credit. And this is just the same thing, except it's a variable. But r squared is right here. R to the third is right there. If there are 5 of them, then it must be r to the fifth. So that's one of our first rules, when to add exponents. Now the difference today is you're going to have these numbers many times in front of the variable. These big numbers here, because they're not these little exponents, these numbers are called coefficients. It's just a fancy word for the big number in front. So that really is 9x squared. Actually, there's a hidden multiplication in there. But anyway, today we're going to see stuff like this. So our problem is 9x squared times 4x to the third. So I'm going to have you do, and these are already worked out, put the coefficients together, put the variables together. See, I kind of broke this apart. And if you think about it, we have 1, 2, 3, 4 parts to this multiplication problem. And we still have 1, 2, 3, 4 parts. I just rearranged them. And we're allowed to do that when we multiply. If you think about it, if I said multiply 2 times 7 times 5, you don't have to go in that order. You can multiply in any order you want. So that's really what I'm doing. I'm rearranging it to make it a little easier for myself. So here, that's still 9 times 4 is 36, like you've always done since whenever you learn multiplication. Now if you look at the second half of the problem, x squared times x to the third is what we were practicing last time. So there you can just add those exponents and get this x to the fifth. Now every year I get this question. Wait a minute, why are you multiplying? You said add. Okay, so there's two different things going on in this problem. Yes, we are adding the exponents when we multiply, see that dot? The same base. But that's still 9 times 4. Okay, so a real common mistake is someone will have 13 here. Okay, because 9 plus 4 is 13. But 9 and 4 are not exponents. So that's the difference. We do not add them. Okay, so this one is just another example. You can see the 3 and the 5 are coefficients. I put them next to each other. Now notice these two terms each have 2 variables. Okay, so I put the m's together. That m squared is right here. This m is right here. And I put my 2 n's together. I have n to the first power and n to the fifth power. There they are. So again, 1, 2, 3, 4, 5, 6 pieces. 1, 2, 3, 4, 5, 6. I just rearrange them and put them together. I kind of think of it as 3 multiplications. 3 times 5 is that 15. M squared times m would really look like m squared times m. Right? How many do you see there? 3. I'm adding the exponents. And if you say, wait, I don't even see an exponent, you can put a little 1 on that m. You're allowed. It's always there. It's kind of hiding. Same here. N times n to the fifth really looks like n times n to the fifth. And if you count, there are 6 of these. And that's why there's a 6 there. Again, you can put that 1 there. So it's getting a little bigger, but it's still the same principles. Add exponents when you are multiplying the same base. And again, that's just 3 times 5. I know this here says you try, but we're going to do these together, and I have 2 more for you to try. Thought the video would be a little long, but I want you to understand this. Okay, so let's see what I would do. I have 2xy to the third times 10x. They have coefficients. I'll put them first. 2 times 10. There's an x. There's an x. Now they're both to the first power. So I just write them exactly how they look. There's a y to the third. You go, hey, that one doesn't have a y. All right. So y to the third is by itself. Nothing wrong with that. So now I'm ready to just get my answer. 2 times 10 is 20 like it's always been. X times x, they both have a power of 1. Let's just x to the second power. I'm adding the exponents. That y to the third has no other y. Well, then just bring it over, put it in your answer. So don't worry about little changes like that. And that's why I wrote number 4. It's the same way. You say, well, there's my 8. Hey, there's no coefficient there. Then the 8's all by itself. And you can probably think that 8 will be over here in your answer because there's no number I'm multiplying it by. So I take my t's. There's t squared. There's t to the third. Put them together. V squared. V to the fourth. Put them together. And now time for the answer. So 8 times, oh, there is no other coefficient. As I said, 8 will show up there. Here are your t's. T squared times t to the third. If you wanted to write them out, you could. And just count them. T to the fifth. What I'm really doing is adding those exponents. And same way with the v's. V to the sixth. Okay. I want you to try these two. And you can pause the video and try it. It's real important you attempt these on your own. Now I'll show you what the assignment looks like. It's just a few of these. Okay, so I'm going to go ahead and do this. I'm guessing you already did. Hopefully you tried them. And here we go. First, coefficients. So again, the second part of the problem doesn't have one. And I already said, don't worry about it. X and x to the third, I'll pair up. There it goes. Y squared and y to the fifth will be paired. And go to your answer now. 10, because there is no other coefficient. And x, again, you can put that little 1 there. X times x to the third. If you wrote them out, you could count them. I'm always going to remind you of that. That's x to the fourth. Y squared times y to the fifth. Add the exponents for the y's. This is a very similar problem. There's no coefficient here, so 7's by itself. I think on the assignment, most of them will have 2 coefficients. Okay? So, I mean, I could change this problem, you know, and put a 4 right here. And if I did that, well then, well, I'm not going to change it because you already solved this, right? You just paused the video and solved it, so I'm not going to do that. But the point is there would be that 4 here. All right, well, on to the m's. M to the fourth and an m. And I see an n squared n to the third. Time for the answer. 7's by itself. I look at those two, and if I were to count them, there would be 5. Again, now it has the hidden 1. M to the fifth, n to the fifth, and I'm done. Okay, so the assignment looks just like that, pretty much. 1 through 4 are just review. Notice there's only 1 space. Just add your exponents. It's just reviewing. You could write them out if you wanted. But when you get to 5 through 14, notice 2 spaces. So on the first space, let's just go to 5 for a second, you'd put the coefficients next to each other. 2 times 5. Then you would put the end of the fourth and the end of the fourth. Okay? Then your answer, just like we did on the example. See how all of these have 2 spaces? That's the end of the assignment. It only goes up to number 14. Do your best, and if you have any questions, message me. I will answer them. All right, I know the video is a little long, but I really want to explain this because we're going to keep moving. You know, the next video is going to have subtraction rules, and the problems will get bigger. So do your best. And until next time, see ya.